minutes. 6, 5, 4, 3, 2, 1.
Right now, we are going through a real revolution in access to space.
Today, commercial companies are providing access, private individuals are flying to space, private companies are supplying payloads to the space station. It's an absolute revolution in relatively cheap and very frequent access to space.
The new space concept is to open up space frontiers through entrepreneurial activity.
I really hope that there are more and more people, country, work together in space, and we need to keep going to expand our frontier in space.
Space tourism will open up brand new opportunities to enjoy our planet.
So many different people can have the opportunity to leave the Earth's surface and to orbit around Earth, or maybe to go to the moon. And that's going to be amazing for people to have a different perspective and to be able to live their dreams.
We are fortunate enough to be amongst some of the first researchers who will go and fly on some of these commercial vehicles. That's coming pretty soon, so I'm starting to get very excited.
People will eventually live off of this planet.
Someday there will be a person who was born in space, lives their entire life in space, and has never even visited planet Earth.
On July 20th, 2021, Jeff Bezos, one of the richest men in the world, owner of Amazon and aerospace company, Blue Origin, reached an unprecedented milestone. He was on board of the first commercial suborbital flight ever to reach the edge of space at an altitude of 107 kilometers.
Now, on how it felt, oh my God! My expectations were high and they were dramatically exceeded.
This pioneering flight lasted just 10 minutes and 10 seconds, with the crew floating in microgravity around 4 minutes.
This is incredible.
Oh, I love it!
Just a few days before, on July 11th, Richard Branson, the multi-billionaire owner of the space tourism company, Virgin Galactic, was on board of his own space plane and also enjoyed microgravity for a few minutes.
I was once a child with a dream, looking up to the stars. Now I'm an adult in a spaceship with lots of other wonderful adults looking down to our beautiful, beautiful Earth.
These two unique space flights shocked the whole world as they kicked off a new age, the age of space tourism.
What we're doing is not only adventure, but it's also important because what we're doing is the first step of something big. This is a big vision, but big things start small.
In this intense competition to give human beings the opportunity to travel to space, SpaceX has taken a step forward. As, just a couple months after these milestones, on September 15th, they launched Inspiration 4, the first all-civilian human spaceflight to orbit. This SpaceX mission reached an altitude of 590 kilometers, much higher than previous suborbital flights, and even higher than the International Space Station. and it spent 3 days orbiting the Earth. This private space flight was the first ever to go into orbit without a professional astronaut aboard. This has been just the beginning of an exciting race in the space tourism business. A thriving business that will allow people to enjoy commercial journeys to space. And this is just the tip of the iceberg of a new economic wave that will change our world as we know it. The space private business.
There is a true revolution occurring in space at this moment. Somewhere along the way, we realized that space also had value. 8 to 10 years ago, space started opening up to the private sector, and that's what defined what is called right now the new space economy. The ability to go beyond just the objectives of space agencies for merely scientific exploration, to opening it up to commercial activities so that other countries, other people can have access to space. And this is the true revolution happening at this moment.
Right now we are living in a very interesting time.
You've got things like novel medical treatment, you got things like space-based solar power, so a lot of these kind of near science fiction ideas that are still very early stage but have a lot of potential. I think that we're going to find things that we never knew even existed.
Everything is changing very quickly in space. The massive emergence of the private sector in space is pushing the presence of human beings off Earth faster than ever before. This whole revolution will allow us to expand outside of the boundaries of our beautiful blue planet and become a real multi-planetary species.
These are the first steps to becoming a multiplanetary species. They will, as one of their first acts, complete what you might call the first stage of human history, which is our transition from being a local species based in the Kenyan Rift Valley to a global species, which we already are in extent. That completes the first stage of human history of becoming what I call a Type 1 civilization, a civilization that has full access to the resources of its planet. Type 2 civilization is one that has full access to the resources of its solar system. Type 3 of the stars. So we are right now on the cusp of completing our history of achieving Type 1 and beginning our history of developing into a Type 2 civilization. There's a famous quote from Tsiolkovsky, a Russian space pioneer, said, "Earth is the cradle of mankind, but one cannot live in a cradle forever."
So this is going to be a slow process, and it's going to be just like on Earth. It will start probably with a base on the moon, in which they can stay for a few more days, weeks, start figuring out how is that they're going to survive in such a harsh environment. And that's going to start evolving into more and more complex settlements on the moon and probably later on Mars.
From Sputnik 1957 through the moon landing, we had tremendous progress in development of space technology. And these were, of course, government-led efforts. The United States, Soviet Union, racing to the moon. They had their running shoes on and they accomplished a lot. But once it lost that drive, we had stagnation, and the cost of space launch from 1970 to 2010 did not fall by $1, which is incredible. I mean, if you think of the advances that occurred in other fields, in computers, for example, where the cost of computers fell radically from 1970 to 2010, and their capabilities increased by thousands of times. But not space, absolute stagnation. But then, starting around 2010, with making the Falcon 9 operational, and then making it reusable, and then introducing a heavy lift vehicle that was 3/4 reusable based off of the Falcon 9, we've had a decline of the cost of space launch of a factor of 5. It fell from $10,000 a kilogram to $2,000 a kilogram.
Please join me in welcoming Elon Musk.
Hi. Hey. Thank you. Actually, so good. It's really crazy that we build these sophisticated rockets and then crash them every time we fly. This is mad. Emphasize how profound this is and how important reusability is. So reusability is absolutely fundamental.
What Musk has done is not only created a number of very impressive and important spaceflight capabilities, and not only cutting the cost of space launch by a factor of 5 over the past 10 years when it had been absolutely flat for the previous 40, but he has set off a private space race.
The key point of this paradigm shift has been the sharp reduction of the costs of launching, thanks to the creation of reusable rockets. Big entrepreneurs like Elon Musk or Jeff Bezos are leading this new private space race with their companies SpaceX and Blue Origin. In addition to these huge enterprises that have taken a gamble on big reusable vessels, there are other companies that are focused on emerging new market, small reusable rockets that could be useful for launching nanosats or other small payloads into Earth's orbit. One of these companies is PLD Space. They are one of the leading commercial projects in Europe in the small reusable rocket industry. Raul Verdu and Raul Torres, its co-founders, have been rocketeers and space enthusiasts all their lives, and they have now managed to design the Mures, reusable rockets based on parachutes to recover one of the rocket's stages.
We work with the European Space Agency, with ESA, since a long time ago. Fortunately, we have strong support from them. We are one of the companies being supported by ESA for small launcher development. They are providing us help in different ways for the development of the launch vehicle and also to help on the operations.
We are now developing Mira 5 rocket with the reusability capability. And Mira 5 is a 2-stage rocket, so we need to develop the mechanism to do the separation of the 2 stages. And this is also a very tricky technology to develop.
It's very focused on the small satellite market, and it's a launch vehicle that can lift off and put into orbit 300 kilograms of payload.
The Mira 5 is PLD Space's main project. It's a 2-staged, partially reusable rocket conceived to launch payloads into Earth's orbit. The first stage of the vessel is the reusable part, and it has been designed to come back to Earth by parachute and land in the sea. After the separation of both stages, the second stage will start ignition and continue to rise until it reaches Earth's orbit, when the fairing will open to allow the payload, mainly small satellites, to be placed into orbit. Both second stage and fairing will eventually be eliminated. The tricky part of this reusable technology is recovering the first stage. PLD Space have developed a spectacular drop test that involves a helicopter and a boat with a crane to grab the booster from the sea.
We developed subsonic test in El Arenosillo in south of Spain, doing a drop test, and we want to demonstrate in flight the reusability capability and the splashdown operation. So we need to use parachutes because of our scale. So our rocket is small and it's cheaper to use parachutes than the engines to do the reusability.
Yeah, that was another important test because involved the use of a helicopter with people inside, two brake pilots, another guy managing when to separate the first stage of Mura 5 from the helicopters. There was a lot of things that never has been at that moment.
Any time that we push the button, it's a very risky operation, not only the launch itself. So we are assuming some risk because we do a lot of work to try to reduce the probability of one of these risks. So it's super easy to fail. We do this with a very successful result. So we are very happy, we are very proud with our technology, and it's very, very promising technology to reuse small rockets.
Reusability has been one of the main drivers for the democratization of space that has allowed us to reach Earth's orbit at much lower cost than years before. So space is becoming much more accessible to us, a place where a promising economy is about to thrive.
We talk about all of new space and the money that could be made, but we should never ignore the literal hundreds of billions of dollars that is being generated right now by the satellite industry.
A few years ago, satellites were as big as a school bus. Amazing advances in software and engineering technology have allowed us to radically reduce their size to devices of less than 10 kilograms, the so-called nanosats. But there are even smaller and simpler versions of these nanosats, the CubeSats, which are cubes of 10 by 10 centimeters and about 1 kilogram in mass.
And I think we're going to enter an era where, if not personal satellites, you're going to have personal satellite capability. You know, not only are you getting your phone, your internet through satellites right now, but soon what was once just the purview of governments in terms of remote sensing capabilities, I think is going to be coming down to the individual.
Small sats have multiple practical applications that are already in use nowadays, from services for communication, meteorology, military purposes, and navigation, to, for instance, the early detection of forest fires. The company Elaine Space is working on a CubeSat named Lume-1 for this very purpose.
Nanosatellites and CubeSats are the most common initiatives and projects in the new space sector. We have developed and launched 4 nanosatellites in the last 8 years. With CubeSats, the standardization of the subsystems has arrived.
In the process of manufacturing a CubeSat, all the subsystems must be tested to prove that all the devices work perfectly. All these tests are carried out in a clean room, a fully sterilized space at the University of Vigo.
We are in the clean room, and in this facility, we usually test all the subsystems of the satellite and also integrate and assemble the satellite. Well, I think it's time to now to load the firmware on the board, okay? Cable connected. Here the UART is ready, okay? So the UART. Alright. And once all the subsystems have been accepted and validated, we start the assembly of the satellite. We start to put all the subsystems together, to wire all the subsystems. And after that, the satellite is ready for flying.
Once in orbit, the satellite searches for and tracks forest fires and sends an alarm signal to a control room, where the data gathered by the CubeSat is analyzed and emergency services are alerted.
Basically, what we do here is to prepare the command sequences and send it to the satellite. The mission of this satellite is to early detect and monitor wildfires. It was built for that purpose. Okay? To do that, we have designed a communication payload built to communicate with sensors deployed on ground all over the world, from wildfire sensors, weather stations, whatever, that they can trigger an alarm when a fire is detected. We can send this data to emergency services so they can arrive there with more information about the fire.
The smallsat's revolution is radically changing the way we connect to space. Until now, most of them are orbiting our planet. However, in the near future, they will also orbit worlds much farther away, such as the Moon or Mars.
It's saying that space has these intrinsic qualities that are very valuable. Things like the microgravity environment, things like the fact that it's a vacuum environment. All of these, we're saying we can actually leverage those into new innovations. And so that's where you start to see this kind of paradigm shift.
Those very special conditions of space that we find at low Earth orbit level open a whole range of possibilities for research in the most diverse fields, from agriculture to nanomedicine, as well as fiber optics, pharmaceutics, or beer production. Multiple sectors are studying how to take advantage of these valuable qualities to improve their products on Earth. In particular, these unique conditions facilitate the processing of certain materials like liquids, gases, or gels in space, as well as the manipulation of huge, heavy structures without effort. This opens up the possibility of starting to manufacture certain items off Earth in coming years.
It has now been demonstrated, for example, that you can make fiber optic cables in space where you have zero gravity that are far more efficient than anything that can be made on Earth. And the value of these things are very high. And so to set up a factory on orbit to actually make this kind of stuff.
In fact, November 2017, will go down in history as the date when human beings were able to manufacture an item off Earth and bring it back to the surface for the first time ever. Dmitry Starodubov, chief scientist at Foams Inc., was responsible for the brilliant scientific program that brought about such a milestone.
Our fiber program is the first commercial effort that generated revenue from manufacturing on orbital platform. We were able to manufacture a small piece of fiber and prove that actually optical fiber manufacturing in microgravity is better than in gravity conditions for specialty optical fibers like fluoride optical fibers, Z-band type. The thermal fields in the microgravity environment provide substantially more uniform and more controllable conditions for material processing that are highly advantageous for materials. We can increase the capacity of data transmission for optical fibers made out of new materials.
We hope that this very first amazing step has been just the first of many achievements that future in-space manufacturing industries will bring about. Without doubt, space is opening up scientific and business possibilities that we hadn't even dreamed of a few years ago. The moon is the next frontier, a place which we walked on 50 years ago, and we're about to go back to in the coming years. And we're not just going there on a return visit, but to settle there permanently. Several private companies are working in fields like mining, human supply systems, transport and energy production, to allow us to establish ourselves on our satellite.
I think the time is coming where something like a lunar base, a lunar colony, adventures on the moon are going to be more commonplace. It's going to have to start small, of course.
The moon is very resource rich. So you do have water ice in the permanently shadowed regions. That's been proven by a variety of NASA missions and other international missions.
We now know that the moon has many interesting resources that could be very useful for future permanent lunar habitats. In order to properly analyze and extract all of those resources, many lunar commercial initiatives have recently thrived. The company Lunar Outpost has been one of the pioneers as they have developed a sophisticated lunar mining rover. The MAP is the first debuted commercial lunar resource prospector, designed to analyze lunar soil in the search for resources. It's prepared to navigate in both light and dark regions of the moon, thanks to a sophisticated camera vision system.
In the future, when we have swarms of these rovers, we'll be able to create a very high-resolution survey of those areas. So as MAP is driving and operating, it uses two different systems to navigate autonomously on the lunar surface. It uses both vision-based navigation system using camera data to scan the surface. However, if you're operating in the dark or in a deep shadow region, the camera won't be able to see in those areas, and so for those situations we have a LiDAR, a laser ranging and detection system, and that allows the rover to see and navigate in the pitch darkness. The rover has scanning spectrometry equipment on board, which is measuring the resources in the surface of the lunar regolith, as well as a drill on board that can probe below the surface. And so again, as the rovers drive around on the surface, they will create a map of these resources and overlay that onto the physical map of the lunar surface.
I think truly we will have robots on the moon within the next year or two. And I'm not talking just one rover here, one rover there. I'm talking swarms of robotic rovers, much like ours, that will be prospecting the lunar surface, finding the resources that will enable that long-term colonization of space, which personally I'm very excited about.
In order to extract and use those resources, we need to study in depth the properties of lunar soil. But we can't go to the moon to do previous analysis. So we have developed various sophisticated tests here on Earth at a small number of scientific institutions around the globe. One of the most renowned is the Colorado School of Mines. They took a gamble on space just a few years ago and launched the Center for Space Resources, a department that is the very first of its kind in the world, as it's fully focused on the study of space resources. For many years, Angel Aboud-Madrid, director of the Center for Space Resources, has been leading a research program focused on human and robotic exploration of space and the utilization of its resources.
The Colorado School of Mines, for 145 years, has been a world leader on the extractive industry. And about 20 years ago, it realized that it could start utilizing all that expertise to identify the resources and extract them and utilize them, but doing that beyond Earth. And so we founded the Center for Space Resources in the late 1990s with the intention of doing basic research on this new era.
At the Center for Space Resources, they have developed multiple tests focusing on studying different aspects of materials found in celestial bodies, like the Moon, Mars, or the asteroids. It's essential to know the properties of lunar soil if we want to mine there. For that reason, they have developed a penetration test to analyze how a probe drills down into simulated lunar regolith. The first step in this test is to prepare the lunar regolith simulant sample to recreate the temperature conditions of the Moon's surface, with temperatures as low as -230 degrees Celsius, so it has been frozen with the help of liquid nitrogen.
And so what we're going to end up doing is, this is kind of our pre-cooling. It's actually a reservoir in there, so we're filling up that reservoir with liquid nitrogen. Then we're going to connect up these hoses while it's in there.
Once the sample is properly frozen and the conditions are similar to the lunar surface, the steel probe can drill down into the soil in order to study its penetration.
Basically, we're taking a probe, which is a small sort of pencil type thing that's made of steel, and we're pushing it down into some soil. This soil is what we typically call regolith, and all regolith is soil on another planet. All the tiny little pebbles and grains of material is called regolith. So what we're doing is we're taking this probe and we're pressing it down into the regolith. And when we press it down in, we measure the forces that occur both in the upward and in all different directions. So we'll see now that we've hit it, you see it kick off. It's going to 40, 50, 60. So once it hits 120 newtons, it begins relaxing. We come back and we do the extraction. The reason for doing that is to kind of understand if we were to land, or we want to extract water, or we want to build a habitat.
To build a habitat on the Moon, the ideas considered are based on 3D printing devices that could work autonomously, using the regolith as raw material to build those future lunar bases, long before humans settle there permanently.
3D printing has revolutionized the way that we can do things in space by allowing us to do complete habitats. We can bring these machines that can start utilizing the material from the moon and start creating all sorts of complicated structures without the need of all this equipment that was thought of before.
At the Center for Space Resources, they've been working hard on developing very innovative 3D printing techniques that use sunlight as the main energy source to thaw the regolith and shape it into new forms or tools. In order to better recreate the conditions of the lunar surface, they use a small vacuum chamber where they test these 3D printing experiments.
3D printing is a process by which we turn materials like this, regolith, into tools, building materials, anything that people might need to live. So the experiments that we do here are learning how to make useful items out of this kind of material. We are going to take regolith and we are going to melt it down using simulated sunlight. I'm going to take the lamp you see behind me, concentrate down the light on that lamp, and melt this regolith into a useful shape.
Once the regolith is thawed, it can be manipulated and shaped to create brand new forms, tools, walls of future lunar habitat, or anything needed up there.
The purpose of this is in the future when humans are living in space and we're going to be able to take sunlight, concentrate it down, and make new tools, new building materials, whatever people need to live, because they're not going to be able to get things shipped from the Earth.
Other worlds much farther away from the boundaries of our planet are waiting for us. The Moon and Mars could be the first places for us to expand into, but they won't be the last. In the future, we will be witness to human beings that were born off Earth and have never visited our planet in their whole life. And even more, they might feel the Moon or Mars to be their homes, as the only sunsets that they have ever enjoyed have set below a horizon of red or gray soil. The first time we walked on another world besides Earth was in 1969, during the lunar landing. Until now, less than 600 people have had the chance to admire our beautiful blue planet from space. Koichi Wakata was one of those lucky ones. In 2014, he became the first Japanese astronaut ever to become commander of the International Space Station.
The reason why I wanted to fly in space, or I wanted to engage in space exploration, is because of Apollo 11 lunar landing. Space is a wonderful place, and I really hope that there are more and more people, country, work together in space. And we need to keep going to expand our frontier in space.
My friend Alan Bean, who flew on Apollo 12 as the lunar module pilot, when he came back from the moon, it really changed his life. He no longer complained about the weather. He used to say, "I'm glad there is weather," right? He no longer complained about traffic. "I'm glad there are people around me," right? So this is what happens when you fly in space. It changes your perspective, and I think for the better, universally. And everybody I've ever spoken to who's come back just marvels at how beautiful our planet is from above.
Space tourism is one of the most promising private industries in this space revolution, and it's going to be the first one to allow anyone to actually move off Earth. After years of difficulties and delays, the space tourism industry finally kicked off last July 2021. As that month, the most important companies in this sector, Blue Origin and Virgin Galactic, performed the first space flights ever with passengers on board. In fact, two of the multi-billionaire owners of each company, Jeff Bezos and Richard Branson, traveled in those pioneering flights and enjoyed the weightlessness for a few minutes on the edge of space and the amazing views of the Earth from such a unique perspective. This was the kickoff for the space tourism race. As just 2 months later, SpaceX proved that they're playing to win as they launched their private mission, Inspiration 4, becoming the first all-civilian human spaceflight ever to orbit. Blue Origin shocked the world again soon after, making the dream of many fans come true, as William Shatner, Star Trek's Captain Kirk, traveled on board the New Shepard suborbital vessel, becoming the oldest person ever to go to space.
Oh, goodness me.
The access of civilians to space won't be limited to tourism, as many people will have the chance to travel to space for many other reasons. For instance, for the first time ever, a movie was filmed in orbit, something unthinkable just a few years ago. A Russian actress and a director spent days on board the International Space Station, shooting a few scenes of the film. Thanks to space tourism, many people will have the chance to travel to the Earth's orbit and enjoy such stunning views of our planet from up there. Not too far in the future, some of the people who have always dreamed of traveling to space and seeing the Earth from above will be able to do so in one of the commercial flights being developed by companies like Virgin Galactic or Blue Origin. Two of those people are Kathy Olken and Dan Durda, scientists at the Southwest Research Institute in Boulder, Colorado, who will be among the very first passengers to test those flights. Dan Durda has been a space enthusiast all his life. He has flown as a pilot many times, but has never been in space, despite having studied it for many years. One of his wildest sci-fi dreams is about to become true.
As a researcher, it helps that I'm also a pilot. So I fly aircraft myself, and I understand what that environment is like. We are fortunate enough here at Southwest Research Institute to be amongst some of the first researchers who will go and fly on some of these commercial vehicles. That's coming pretty soon, so I'm starting to get very excited.
Like Dan Durda, Kathy Olken has also dreamed of becoming an astronaut since she was a child. Soon it will be her turn to experience that indescribable sensation of floating like a feather in microgravity.
I've wanted to go into space for a long time. I applied to be an astronaut and I didn't quite make the cut. And so this is a way to be able to carry out science experiments in space.
Both of them have been training hard on board zero-G parabolic flights to be properly prepared for future real suborbital flights, as the accelerations and forces they will be exposed to on those flights will be quite demanding.
We've been looking forward to it for a while. We've been training and getting prepared, doing parabolic flights on airplanes where you can simulate zero-G, and going in a centrifuge where you can experience high gravity forces. And I just really look forward to being able to fly in space.
We have been spinning in centrifuges to feel the accelerations of the launch phase and the re-entry phase of a flight like this. We've been flying high-performance jet aircraft, military aircraft like the F-18 or the F-104, to again feel the accelerations, to have the sensation of what it's like to have all the extra equipment that we might have on our bodies.
The very first commercial flights will probably be suborbital flights, just leaving Earth's surface, rising into space, and coming back down.
You're going to accelerate up through the atmosphere, whether it's on a rocket or on a rocket plane. Then essentially coasting over the top on a parabolic trajectory up and out of the atmosphere, peaking at altitude something like 100 kilometers, 60, 70 miles up, something like that. Before then, gravity is still pulling on you, dragging you back down to the Earth, back through the atmosphere. That total flight time, depending on the type of vehicle, whether it's a rocket plane or a rocket itself, might be 15 or 20 minutes.
There are 3 companies leading the race in space tourism with suborbital flight prototypes: Virgin Galactic, Blue Origin, and SpaceX. Virgin Galactic was the pioneer, the first to take a gamble on suborbital flights.
Virgin Galactic, and they have a space plane called Spaceship Two, carried on a large carrier aircraft. The basic design, the idea, was developed way in the early 2000s by Burt Rutan and his company Scaled Composites. He was coming up with a very innovative aeronautical designs to allow pretty frequent and relatively inexpensive access to the high atmosphere. And once that was shown successful, Richard Branson's Virgin group of companies, a little light bulb went on, and they said, we want to license that capability and build that as Spaceship Two, as Virgin Galactic, to allow people to buy tickets to space.
But Virgin Galactic is not the only one in this upcoming business, as Blue Origin, belonging to multi-billionaire Amazon owner Jeff Bezos, has also invested very heavily in the development of its own suborbital spacecraft. Both companies, Blue Origin and Virgin Galactic, performed the first commercial suborbital space flights in July 2021, being Blue Origin the only one to overpass the Kármán line, which is established at an altitude of 100 kilometers, what is the so-called edge of space. These suborbital flights will not just allow us to enjoy breathtaking views from up there, but also they will help us to fly from one corner of the Earth to another in less than 1 hour, as those flights will take advantage of the fact that at such high altitudes, atmosphere density is almost non-existent, so that drag is close to zero and speeds could be much greater.
You can go from anywhere to anywhere in less than an hour. A flight from Los Angeles to Sydney might cost the passenger $20,000. But people who fly first class from Los Angeles to Sydney pay that right now. They still have to spend 18 hours in the airplane. They'd get to Australia in less than an hour, and for half of that hour, they'd be in space, experiencing zero gravity and seeing the incredible black starry sky of space out through the window while they fly. Now that's value delivered. So I think that's a business that'll happen.
To have this opportunity to actually go up to space and see what our planet looks like from above. And I think that's going to revolutionize the way we think about ourselves and relate to each other here on the planet.
The future is now here. A new age is about to begin. Human beings will no longer be a species strictly moored to one planet. The space industrial revolution has been the definitive driving force that has pulled us forward off Earth into multi-planetary expansion. That dark, starry sky will no longer be the limit.
Do we have the need to become a multi-planet species? Did we have the need to leave the Kenyan Rift Valley? I mean, you know, humans, in a very real sense, are not native to the Earth. We're native to Kenya. We are actually tropical animals. That's why we have these long, thin arms with no fur on them. No human in the true state of nature could survive a single winter night in Colorado or in most of Europe. They would die. It takes technology to live out of the tropics. We had to develop clothing. It's a technology. We had to develop houses. We had to develop fire and many other new capabilities to become a global species.
We're sort of in the stage of these first tentative steps in our species becoming an interplanetary species. If we want to protect ourselves as a species and ensure that we survive for a long period of time, we want to be diversified off of this planet.
Earth is the cradle of mankind, but one cannot live in a cradle forever. Earth is indeed the cradle, and it's in the cradle that a child develops the capabilities that allows them to leave the cradle and go to the schoolyard, okay? The solar system is the schoolyard for going to the stars.